Okay, this is Mr. Peterson, and we're looking at the notes for Algebra 2, Section 4.3, starting on the second page. On the first page, we learned how to multiply by a scalar, and I promised you then that I would try my best to show you why just a number that you're multiplying in front of a matrix is called that weird name, a scalar. So here we go. Matrices are sometimes used or often used in graphic design of digital gaming, and the points on whatever image is on screen are represented in matrix format. So I have a very simple example of that right here. We have, hang on here, we have these 3 points here, A, B, and C, and you can see that I've transferred to them this little 3 by 2 matrix, with the 1, 4 being point A being at the top. Once you have that 3 by 2 matrix, there's 3 points, and each of them has an X and a Y coordinate is how that's set up. You're going to multiply that by some scalar, just to illustrate why we call it a scalar. In this case, I'm going to multiply everything by 2. And what that'll give me is 3 new points. And you remember last time you just multiply all these numbers by 2 in this case, so it's going to be 2, 8, and that's this point up there. 5, negative 1 becomes 10, negative 2, and that's this point B prime down there that is the image of the old point B that was right there. And then this is point C right here, but when you multiply by 2, C prime, or the image of C, goes to 6, negative 4, and you can see that's that location down there. So if you draw the new image, you find out that you're just getting a bigger version of the previous. So the new triangle is the same shape as the original, it's just a different size. And another name for size is scale. And the action that's responsible for making this twice as big is multiplying by that 2. So we call the number in front the scalar because it changes the scale of the object. Now this is used all the time. You guys use it on your cell phones when you either pinch or spread to make an image bigger or smaller when you resize an object. Sometimes you click on some sort of zoom icon. It might be a plus sign and a minus sign, or a magnifying glass. On the back of a digital camera, there's a little lever that says wide angle and telephoto, and you can zoom in or zoom out. And without realizing it, every time you do these actions, you're using scalar multiplication internal to the workings of the device. Okay, so what I'm going to do here is just use scalar multiplication for a practical problem. You have a very limited menu at this little restaurant here. Maybe it's just a sidewalk cafe or something, and it's got, they sell chicken dinners and hamburger and fries. And they do give a price break for children, so you can see their price structure is listed in this matrix format here. And we're going to be increasing the prices by 20%. Perhaps the labor prices went up or something, or the price of supplies, and they need to increase their costs or increase their prices to reflect that increase in cost. Okay, so the first thing to do is figure out what to do with this 20% increase. Now it does say increase, and when you have increase or decrease, that's always either added or subtracted from 100%. because you're increasing it on top of the original price. So 100%, that's the original price, plus an extra 20% added on to it. And that turns out to be 120%. 120% is 120 over 100, or 1.20. We'll shorten that to 1.2. And then we use this in the scalar multiplication. So all I'm going to do here is multiply the old prices by 1.2 to get my new prices. And then just so you understand that the interpretation of this here, the old price for a chicken dinner for a child was $5.80. It has gone up to $6.96. I'll give one more example here of how to interpret this. The hamburger and fry price for an adult used to be $7.50, and it now has gone up to $9. So you can see the prices have increased in each case by 20% being added on. Okay, the properties of scalar multiplication. If you have matrices A, B, and O that are m by n matrices, in other words, they're the same size, so they might all be 3 by 2 matrices or 2 by 4 matrices. And then you have C and D representing in this little box scalars, like maybe 6 or 1/2. Then if you multiply C times A, you get another m by n matrix. It's called the closure property. I usually don't require students to know that one. And then the next one here is if you have C times D, both of them scalars, and you're multiplying that by A, then you can regroup it and say D times A, and A is a matrix, and then times C later, and that's called the associative property. That works with scalar multiplication. The distributive property comes in two formats. In the first example here, we're multiplying a scalar, oops, hang on, let me get a highlighter going. A scalar times the sum of two matrices, then you can distribute, that's what this property is, the scalar across both matrices. So that would look like this. The scalar C times matrix A plus the scalar C times matrix B. But then there's another version of that where you have two scalars added together times a matrix. And that one you can distribute coming this way, C times A and D times A. So either the scalars distribute or the matrices distribute, either one. Okay, the last two properties are ones you're familiar with. If you multiply by a scalar of 1, you'll get your matrix right back. That's called the identity property. And finally, if you multiply a scalar 0 times A, you'll get either a matrix filled with zeros, or if you take a scalar times a matrix that's full of zeros, you get another scalar full of matrix full of zeros. And I know that's confusing, but I'm not going to worry about that last one there until later in this course. Okay, so there's the properties that go with scalar multiplication. And we'll pick up on page 3 in the next video.